This is what it gives you. Okay, and then what we're going to do directly is we're going to have a function that tells us how to switch the pitch. So going from one pitch to another is one frequency to another. So what I mean here is that if A originally is 440 Hertz, then we want a new A, we call it A prime. Let's say it is 528 Hertz. Then we are going to have, we call this F0 or F0, and then here we're going to say F prime. So we have two things. So we're going to see how to quantify this. So we search, how does sense relate to frequency? We want to see if there is a mathematical relationship between the two. And then we scroll. We go on Wikipedia and we find exactly what we need. So we're going to write a function. Which one am I? So we're going to write a function. So we don't write function in here like that. We do this. Why do I do that? Is because I use MATLAB a lot. I like MATLAB more than I like Python. What am I going to do? I say, so it's not always nice to have a good function name. So my function name here is going to be getSense. I don't know if I should use plural. Okay, so what we're going to be needing is F0, F prime. And that's it. Why is that? Because our function looks like this. So it's 1200 log 2 and F2 over F1. So we're going to say, okay, we're going to have Cint equals 1200 times numpy log 2 Fp over F0. So it's really important that you know, say you have a concept of knowing what is that you want to be F1 to be and F2 to be, because you can convert F2 to F1 by this relation. It's actually a rewritten relation in here. So it's important that you know exactly which one that you want. So here we can write one function already, and this already return send. So this is the output. The return value is what spits out after running this function. So, and then what is NP? It is that import numpy as NP. And here this is not needed because we didn't call it. So you see, a clean version is that you always only have what you needed. You don't have anything that's not used before or after. So, and then how to run this is command return. It's command return if you have a Mac. If you have Windows, you know what to do. It's control, right? I don't know. Is it shift? I don't know. Anyways, so you, after doing this, you already have a function. So how do you do this? Is that you do send equals get send, and then say F0 is 440, and then we have 598, and then you can say, oh, I would like a printout, and then you have 315.6. So you can always make sure what it is. What was what? Okay, so you can check sense converter online. This is frequency. You can always do this, and then you can also do this. So someone already wrote things like this. So frequency 1 is 440 right here, and then here is 528. And then you will see the sense between frequencies is 315. So here 315.64, we have this as well. And then what we need to know, next step, is that Okay, we find out the relationship between scents because we wanted to know the relationship between the two frequencies. And then you want to ask how to shift the entire song accordingly. So actually, how did I approach this? Let's be real here. I wanted to use librosa because librosa itself is a Python package for music and audio analysis. So I believe that it must have a lot of designed user-friendly functions that are going to help me to get to the point where I can do a pitch tuning. So if you already know that librosa is the thing that you wanted to use, you could just do this. And then what you're going to do, what are you going to do is that you're just going to look into its manual, and then you're going to find what you want. So you're going to try a lot of things. If, say, I'm not playing with this thing with you right here, and then what you're going to do is that, I see that there is a pitch tuning thing, but a pitch tuning thing, just, you see, it gives out the tuning deviation in terms of the fractions of the bin, and then it doesn't return the array of the song. So you understand that this is not the destination. I would like to have a song that shifts the frequency accordingly. So you then try to do different things. You see there's called pip track, and then you will see that it does the Fourier transform, and then it returns. What does it return? It returns pitches and magnitudes. Also, it doesn't give you the things that I want. So what I'm going to do is that I'm going to say I want to have a pitch shift. So it really mattered of that what you know you want. So wanting the output of a pitch shift is exactly what you wanted, and then you might see end steps, bins per octave, things, and then after going through some trying different functions, you'll find that this is what you need. Actually, it's called pyrubberband. I read it on Stack Overflow, I think. I Google everything all the time because I refuse to remember it. We'll talk about ArcPath later. So this is what I went through. It's not pretty. That's why I always keep things open. Yeah. Okay, so you see, this is exactly how you do your research, is that you search for things and then you go down and you see that why people recommend it is because not because of its good reputation, but actually it says that there's signal reconstruction through a particular algorithm. If you're interested, you can always go into these, but if I only wanted the result, I just don't give a, you know what, I just don't give a, that's basically what goes through my head. Like, I don't care, I just want it to work. And then what you do is that you search this and then you go into the documentation again, and then here you see, this is exactly what I want. I want a pitch shifted audio directly. I don't care what goes on inside. You can care, but if you're not developing this thing, you just wanted the music like I do, you can just do this, and then you see this is a function that you want, So what you want to do right now is that you realize that, oh, I did not install this thing, because you see, usually we have numpy dot whatever, and it means that I don't have a numpy, so I don't have this module. So I go back, I run this already, and then so then I just say, okay, I'm going to conda install again. See, it does not offer. So what you're going to do this conda install. If you ran out of possible way to install it, you pip install. So you can always check which pip you're using. See, I'm using the mini conda one, and let's see, yeah, this is not the terminal that I'm using. So you can conda activate, or because we're going to, where is my terminal? Where is my terminal? Yeah, this one. So what you're going to do is that you are going to be safe, and then you're going to save this file, see checkpoint now, and then you interrupt it, Control C 2 times, so it's no longer interactive. So I'm gonna go ahead and close it. And then what we're going to do is that we use the same thing, and then we were in this conda environment, right? And then we pip install. Yay! And then we have pyrubberband, and then what we're going to do is we're going to conda activate it again. Oh wait, no, what the hell? Oh, I was distracted for a moment. Okay, I'm going to activate it again. I'm sure that there is a better way than interrupting the kernel, but that's fine because we only have a few. And then we see that we've moved on to wanting the relationship of F0 and FP to want to have to use this so that we have a pitch shifted audio directly. We don't want to go through extra steps. Simplicity. Okay, so what we're going to do is that we want to use this, right? So we import the module. From this module, we import this, and then we can directly call this. So we can have y shifted equals this, and then y sampling rate and steps. So now we're not conflicted, because it says that semitones. What the hell is semitones? So semitone relation to send. We just look up for it, or you can just easily work on whatever people already worked on. See, it says that you see, oh, about 100 times of a semitone is sent. So we also Google to make sure if it's true. Oh, it says that 100 cents each. One semitone. 100 cents each. So easy. We're just going to say get semitones, and then semitone. And then we're going to say 100 cents each, right? So this is semitone. ST. Semitone. Let's be clear. Okay. So then we have n steps.